Good afternoon, Engineer Gonzales, and good afternoon, classmates. We are the Group 1, and we will be discussing about the analog and digital measuring and testing instruments. So before we tackle the definition and uses of each measuring device, we will be explaining first what are analog and digital instruments. So there are many other types of measuring instruments that measure various other things. Regardless of what you are measuring, the instrument you are using may have either a digital readout or an analog readout. So what are analog instruments? An analog instrument gives an output that varies continuously as the quantity being measured changes. The output can have an infinite number of values within the range that the instrument is designed to measure. So analog instrument displays the result in a form similar to that of a ruler or in a scale. A needle, which is the indicator, point to the correct measurement. So next is digital instrument. A digital instrument displays an output that varies in discrete steps and so can only have a finite number of values. So digital readouts are the simplest to read since the resulting measurement is given in numbers. So what are the difference between these two measuring devices? Basically, the difference between analog and digital instruments is their output. The output information of an analog device or analog instrument is shown by a pointer, while the digital instrument output information is shown by digits or in a numerical form. So, to further explain the uses and definition of each measuring device, Miss Sabela will explain it further.
So the first type of analog and digital measuring and testing instrument that I'll be talking about is the common one, which is the multimeter. So what is a multimeter? A multimeter measurement is a measurement device that is often known as a voltometer, wherein most engineers and technicians in the electrical and electronic fields are familiar with. Multimeters comes in a variety of shapes and sizes depending on their use. A multimeter is necessary measurement tool in any engineering workplace or laboratory. This device's main purpose is to measure electrical voltage, current, resistance, and other parameters of electrical properties of tools and industrial wires. Multimeters are now utilized for a variety of purposes, including dealing with electricity, laboratories, power sources, and circuits. On the front side of the multimeter, a dial or a rotary switch could be used to select the various and electrical parameters. So, how to use this multimeter? The function and operation of a multimeter are similar for both analog and digital multimeters. This instrument has two red and black LEDs or probes, as well as 3 ports. The black color LEDs goes into the common port, while the red color LEDs goes into the different ports based on the requirement needed. When LEDs have been plugged in, the knob in the center of the instrument can be turned on to conduct the proper function for the component being tested. When the knob is set to 20 volts direct current, for example, the multimeters will detect DC voltage of up to 20 volts. So the second type of analog and digital measuring and testing instruments is the voltmeter. So a voltmeter is a device that measures the difference in voltage or electrical potential between the 2 points in a basic electrical circuit. Analog voltmeters have a pointer that moves across a scale in proportion to the circuit voltage. So voltmeters range in precision from a fraction of a volt to several thousand volts and are used with voltage ranging from a fraction of a volt to several thousand volts. The direct current and alternating current are the two most frequent voltage measures. Although voltage measurements are the simplest of the various forms of analog measurements, noise issues create distinct obstacles. So analog voltmeters move a pointer across a scale in proportion to circuit voltage, while digital voltmeter utilize a converter to display voltage numerically. We have a analog voltmeter and digital for the types of voltmeter. So the analog voltmeter is simple compared to other measuring analog and digital instrument multimeter. This analog voltmeter, the AC voltage is measured with an analog voltmeter. The reading is displayed using a pointer that is fixed on a calibrated scale. The torque acting on the pointer determines its deflection. The magnitude of the developing torque is proportional to the voltage being measured. Deflecting type indicating voltmeters are included in the analog voltmeter. And these voltmeters are similar to moving iron, moving coil, and electrostatic voltmeters. Permanent magnet and dynamometers instruments are two types of moving coil devices. So, moving coil instruments, and this is a permanent magnet field with will only respond to direct current. Moving coil instruments are made up of a permanent magnet that generates a magnetic field in a coil wound on a soft iron component that revolves around its own vertical axis. Deflecting torque is produced as current flows through this coil. According to the Lorentz force equation, this torque is proportional to the voltage across the circuit in question. So another type of analog and digital measuring and testing instrument is the ohmmeter. An ohmmeter is an electronic device that is primarily used to calculate the electrical resistance of a circuit. The unit of resistance is the ohm. Electrical resistance is a measurement of how well an object resists current passage through it. Micro, mega, and milliohmmeters are examples of this distinct types of meters with differing sensitivity levels. The microhmmeter is used in bonding contact applications to calculate extremely low resistance with great precision at speed test currents. Also, while a microhmmeter is a small portable instrument that can be used to calculate current, voltage, and test diodes. This sort of meter has various choices for selecting desired function, and it ranges most measurements automatically. For the megaohmmeter, it is primarily used to determine huge resistance values, while the milliohmmeter is useful for determining low resistance with great precision in order to validate the electrical circuit values. So, the working principle of an ohmmeter, when a battery, a series adjustable resistors, and a reading instrument are all linked to the instrument, at terminal OB, the resistance to be measured is a touch. The circuit current flows when the circuit is completed by connecting the output resistance, and the deflection is measured. When the resistance to be measured is extremely high, the current in the circuit is extremely low, and the instrument's reading is presumed to be highest resistance to be measured. When the resistance to be measured is 0, the instrument reading is set to 0 and the resistance is 0. So for the types of ohmmeter, first type of ohmmeter is the series type ohmmeter. The component that we wish to measure can be linked in series with the meter in series type ohmmeter. When there is no current flowing through the meter, it shows infinite resistance, and when there is a large current flowing through it, it shows 0 resistance. For another type of this ohmmeter is the SHAWN ohmmeter. So when calculating component is linked in parallel with the battery, a shunt type ammeter can be connected. The low value resistance is calculated using this type of circuit. The meter, the battery, and measuring component can be used to create the circuit below. So for the third type of this ammeter, which is the multi-range ammeter, so the range of a multi-range ammeter is extremely wide, and this meter has an adjustment that can select the meter's range based on the necessity. So the other type of analog and digital measurements and testing instrument is the oscillopes. So what is an oscillopes? The waveform of electrical signals is displayed and analyzed using an oscillop, which is a laboratory device. The device, in effect, plus the instantaneous signal voltage as a function of time on graph. A common oscillopes may be display waveforms of alternating current or pulsating direct current at frequency ranging from 1 Hz to several megahertz. Oscillopes with this resolution can display signals with frequency up to several hundred gigahertz. The display is divided into horizontal divisions and vertical divisions. On the horizontal scale, the time is displayed from left to right. Instantaneous voltage is displayed on a vertical scale with positive values ascending and negative values descending. The cathode ray oscillopes is the oldest type of oscillopes and is still used in some laboratory nowadays. This oscillop creates an image by generating a concentrated electron beam to sweep across the face of a cathode ray tubes in patterns. Modern oscillopes use a liquid crystal display similar to those seen on notebook computers to electrically create the action of the cathode ray tube. So computers are used to process and show waveforms in the most advanced oscillopes. Any sort of display, including cathode ray tube and LCD and gas plasma, can be used in these computers. The horizontal sweep of an oscillop is measured in seconds per division, milliseconds per division, microseconds per division, or nanoseconds per division in any oscillopes. So volt per division, millivolts per division, or microvolts per division are units measurements for vertical deflection. Horizontal sweep and vertical deflection parameters are changeable on most all oscillopes.
Digital multimeter. A digital multimeter is a measuring instrument that can measure quantities such as voltage, current, and resistance. Measured values are shown on a digital display, allowing them to be read easily and directly, even by first-time users. So there are 3 types of digital multimeter. First is the Fluke digital multimeter. A Fluke digital multimeter is used mainly for calibration efforts. It can be used to calibrate volts, currents, and other electrical units. Next is the clamp digital multimeter. A clamp digital multimeter uses built-in tools to measure electrical flow. It combines a digital multimeter with a current sensor. Clamps measure current and probes measure voltage. The last type of digital multimeter is the auto-ranging digital multimeter. It is often used for easier projects. They are fancy multimeters that are auto-ranging, meaning they automatically change their internal range to attempt to find the correct voltage, resistance, or current of the thing you're poking at. So for the next one, signal generator. Signal generators are one of the most essential pieces of technology in electronics and communication. It is used to produce different types of signals and frequencies for a variety of purposes such as testing, troubleshooting, and designing. Next is ammeter. Ammeter is an instrument for measuring either direct or alternating electric current in amperes. An ammeter can measure a wide range of current values because at high values, only a small portion of the current is directed through the meter mechanism. And lastly, frequency counter. Frequency counter is an electronic instrument or a component of one that is used for measuring frequency. Frequency counters usually measure the number of cycles of oscillation or pulses per second in a periodic electronic signal.
Spectrum analyzers are key test instruments for using when testing radio frequency, RF circuits, modules, and units. They are used in many areas, including RF design, general electronic circuit design, electronic manufacturing, and test, service, and sometimes in field repair. These test instruments display amplitude against frequency, and as a result, these test instruments are key in locating spurious signals and displaying and measuring signal bandwidth. One of the key ways to understand how to use a spectrum analyzer is to look at the controls. Although the test instrument may look complicated, it can be easy to understand how to use once a little time is spent with one spectrum analyzer. Function generators, or waveform signal generators, are instruments that output signals with various amplitude and wave frequency. Modern instruments like this can output sine, square, and triangles at the same time. Engineers use them to act as a circuit clock, test filter, and a character amp circuit. Logic analyzer is an instrument for capturing, displaying, and measuring multiple electronic signals simultaneously in a digital circuit. Logic analyzers are capable of showing the relationship and timing among many different signals in a digital system and are often capable of analyzing digital communication protocols such as I2C, SPI, and serial. As a result, a logic analyzer is the best tool for debugging digital circuits and digital communication systems. Once it runs, it shows the digital waveform that gives fine values based on the range of voltage between high and low in a 1-bit resolution, which is 0 and 1. The logic analyzer goes farther. It can capture state mode data, and with a high channel count, it has a greater analytic depth and insight. Logic analyzer has an interface in a PC software. With connection with other external devices like Arduino, you can do it to another level. Continuity analyzers or continuity testers are electrical test instruments that are used to determine if the electrical circuit exists between 2 points. They consist of an indicator that is connected in a series with a power source and 2 test LEDs or probes. The indicator is activated if the probes detect complete circuits between the 2 LEDs. Some continuity testers have visual indicators such as light-emitting diodes or LEDs. Other feature audible buzzers, and other for high-resistance circuits have an application that involves sensitive electronic components. Low voltage and low current continuity testers should be used. Typically, these devices contain an optimal amplifier or an op-amp.
So the LCR meter. The LCR meter is a meter ideal for performing direct and precise measurements of inductors, capacitors, and resistors using different test frequencies. The LCR meter's term signifies its function wherein it can act as a multimeter which can measure inductance that is represented by the letter L, the C for capacitance, and the R for resistance as per the requirement. The basic use of LCR meter is to measure, well of course, the L, C, and R as mentioned. But LCR meter can also determine the impedance, the complex resistance created by the alternating currents. The impedance is measured internally and converted for the display to the corresponding capacitance and inductance value. Readings should be reasonably accurate if the capacitor or inductor device under test does not have a significant resistive component of impedance. The LCR has two main techniques, namely the bridge method and the current voltage method. Bridge method uses the familiar Wheatstone bridge concept as the basis of its operation. The aim is to aim balanced point at the bridge component. This method is typically used for lower frequency measurements. Often measurement frequencies up to 100 kHz or so are used. The current voltage method or the current voltage measurement, however, is normally used for components that are used for higher frequency applications. Next up is the network analyzer. Network analyzer is an instrument that measures the network parameters of electrical networks. Network analyzers are often used to characterize two-port networks such as amplifiers and filters, but they can also be used on networks with an arbitrary number of ports. Network analyzers are used mostly at high frequencies. Operating frequencies can reach from 1 Hz to 1.5 THz. Special types of network analyzers can also cover lower frequency ranges up to 1 Hz. These network analyzers can be used, for example, for the stability analysis of open loops or for the measurement of audio and ultrasonic components. The two basic types of network analyzers are the scalar network analyzer, which measures the amplitude properties only, and the vector network analyzer, or the VNA, which measures the amplitude and the phase properties. A VNA is a form of radio frequency network analyzer widely used for RF or radio frequency design applications. A VNA may also be called a gain phase meter or an automatic network analyzer. An SNA is functionally identical to a spectrum analyzer in combination with a tracking generator. As of 2007, VNAs are the most common type of network analyzers. And so, references to unqualified network analyzer most often mean a VNA. 5 prominent VNA manufacturers are Keysight, Anritsu, Rode, and Schwarz, Copper Mountain Technologies, and Omicron Lab. Another category of network analyzer is the microwave transition analyzer, or MTA, or a large signal network analyzer, LSNA, which measure both amplitude and phase of the fundamental and harmonics. Now for the next one, the digital pattern generator. The digital pattern generator is a piece of electronic test equipment or software used to generate digital electronic stimuli. Digital electronic stimuli are a specific kind of electrical waveform varying between two conventional voltages that correspond to two logic states, namely the low and high state, or represented in binary as 0 and 1. The main purpose of a digital pattern generator is to stimulate the inputs of a digital electronic device. Digital pattern generators are sometimes referred to as pulse generator or pulse pattern generator, which may be able to function as digital pattern generators as well. Hence, the distinction between the two types of equipment may not be clear. A digital pattern generator is a source of synchronous digital stimulus. The generated signal is interesting for testing digital electronic at logic levels. This is why they are also called logic source. Digital pattern generator can produce either repetitive or single-shot signals, in which case some kind of triggering source is required, internal or externally. Digital pattern generators are today available as standalone units, add-on hardware modules, for other equipment such as a logic analyzer or as PC-based equipment. Lastly, the digital storage oscilloscope. A digital storage oscilloscope or DSO is an oscilloscope which stores and analyzes the input signal digitally rather than using the analog techniques. It is now the most common type of oscilloscope in use because of the advanced trigger, storage, display, and measurement features which it typically provides. The input analog signal is sampled and then converted into a digital record of the amplitude of the signal at each sample time. These digital values are then turned back into analog signal for display on a cathode ray tube, or transformed as needed for the various possible types of output: liquid crystal display or LCD, chart recorder, plotter, or a network interface. Digital storage oscilloscope costs vary widely. Benchtop self-contained instruments complete with display start at $300. Digital oscilloscope usually analyzes waveform and provide numerical values as well as visual displays. These values typically include as maxima and minima, root mean square, and frequencies. They may be used to capture transient signals when operated in a single sweep mode without the brightness and writing speed limitations of an analog storage oscilloscope.
That's it for our report. Thank you for watching, and we hope that you learned something from our discussion.